Okay, so I'm going to be doing 627 times 412 using the lattice method and then comparing that to the standard algorithm. So first, I'm going to start by doing the ones place times the hundreds place. So 7 times 4, which is 28, and then 7 times 1, which it would be 0 times 1, or 0 and then 1. 7 times 2, which is 14. 2 times 4, which is 8. And I have to put a 0 here for this one and this one because I have to hold the place value. Since there isn't a number in this place value, I still have to account for it by putting a 0. 2 times 1, I put here, is 0 and then 2. 2 times 2 is 0, then 4. 6 times 4 is 24. 6 times 1 is 6. 6 times 2 is 12. So then, from here, what I will do is I will add going this way. So I add every single here, 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 and here. So I add every single place value. So first I'm going to add here, and this would be 4. Then I add 4 plus 1 plus 1, which is 6. Then I add 2 plus 2 plus 8, which would be 12. And then I carry the 1 over to the next place value. So then I do 1 plus 1 plus 6 plus 8 plus 2, which is 10, plus 6 is 16, plus 2 is 18. Put the 8 here, carry over the 1, and then I get 5 from here, and then I have 2 here. So my answer is 258,264. So how that compares to over here is I'm doing the same exact multiplication of 7 times 2, which is what I did here, which would be 14. But instead, I'm going ahead and carrying over and doing all that all at the same time. Then I do 2 times 2, which is 4, plus 1 is 5. So I get the same thing. 2 times 2 is 4, so that's where that 4 comes from. Then I do 6 times 2, which is 12. I put a 0 down to hold my place. Then I do 7, 1 times 7, 2 times 1, 6 times 1. And the same thing is what I did over here. I did that all here. So we have the 2 times 1 is here, and then we have the 6 times 1 is here. And then moving on, I have to add 2 zeros. And I do the same thing here. 4 times 7, which is 28. And then I get 8 plus 1 is 10, or plus 2 is 10. And then 24 plus 1 is 25. So then I add all of these together, just as I added all of these in these particular place values. I'm still adding here. So then I do 4, and then I have 12, carry the 1, and then I have 12 plus 3 plus 1 is 13. Then I have 8, and then 5 and 2. And it looks like I did my math a little bit wrong because I got 2 different answers. Let's check that. 10, 12, 13. I think I did something wrong up here with my multiplication. Well, regardless, that should be the same answer. But how they work, the difference is, so this one works because you multiply every place value. So here you're multiplying the ones place times the hundreds, then you're multiplying the tens by the tens, and then the then the hundreds by the ones, and you multiply them all just as you do here. So here you're multiplying the ones place by the whole number, then the tens place by this whole entire number, and then the hundreds place by this whole number. So you're doing the same exact work, just in a different display. And so, yeah, so you should get the same answer. Obviously, I did something wrong with my multiplication, but you should get the same answer with both, and they both work because you're doing the same process, just in a different order and a different way. But yeah, that's the lattice method and the standard algorithm.